Hello everyone. Now I am going to explain about venturimeter. Venturimeter is a flow measurement device which is based on the principles of Bernoulli's equation. Inside the pipe, a pressure difference is created by reducing the cross-sectional area of the flow passage. The difference in pressure is measured with the help of manometer and helps in determining rate of fluid flow or other discharge from the pipeline. Venturimeter has a cylindrical entrance section, converging conical inlet, a cylindrical throat, and diverging recovery cone is there. What are the components of venturimeter? I mean, there are very important main parts are cylindrical entrance section. In this section, having the size of a pipe to which it is attached. The venturimeter should be proceeded by straight pipe of not less than 5 to 10 times of pipe diameter, and free fitting and misalignment and other source of large scale turbulence. Okay, next one is converge conical section. The converging take place at an angle of 21 plus or minus 2 degree. The velocity of the fluid increase as it passes through the converging section, and correspondingly the static pressure falls. Okay, next one is throat, other important principal component. This is a cylindrical section of minimum area. The velocity is maximum and the pressure is minimum. The throat diameter is usually between half and quarter of inlet diameter, and length of the throat equals its diameter. And next one is diverging section. This is a section in which there is a change of stream rate area back to the entrance area. The recovery of kinetic energy by its conversion to pressure energy is nearly complete, and so the overall pressure loss is small. To accomplish a maximum recovery of kinetic energy, the diffuser section is made with an inward angle of 5 degree to 7 degree. This angle has to kept less so that the flowing fluid has the least tendency to separate out from the boundary of the section. And what are the different types of venturi tubes here available? A standard long form or classic venturi tube, and a modified short form where the outlet cone is shortened, and an eccentric form of handle mixed phases or minimize buildup of the heavy materials. A rectangular form used in duct area. The major disadvantage of this type of flow detection at high initial cost for installation and difficulty in installation and inspection. The venturi effect is reduction in fluid pressure that result when a fluid flow through a constricted section of pipe, and the fluid velocity must increase through the construction to satisfy the equation to continuity, while its pressure must decrease due to the conservation of energy. The gain in kinetic energy is balanced by drop in pressure or a pressure gradient force. An equation for the drop pressure due to the venturi effect may be derived from a combination of Bernoulli's principle and the equation of continuity. The main objective of in this experiment, what is the main objective? To determine the coefficient of discharge the given venturimeter. Then what are the apparatus are required in this experiment? Venturimeter and differential manometer and a collecting tank, piezometer, okay, and any stopwatch device and measuring scale. The first step is a pipe required diameter is selected and other are kept in closed position. Normally, see in this venturi Orifice nozzle testing, venturimeter 25 mm and Orifice meter 25 mm, throats dia both are same 16.77 mm, and nozzle meter is 25 mm, differential manometer 1 mm range, and delivery size is 40 mm. So already I told the first step, a pipe of required diameter is selected and other are kept in a closed position. Then second step is the main inlet valve is open to allow water to flow through a selected diameter pipe. Open the pipe valve and change the knot manometer from isolated position to air vent position to remove the air inside the pipe. Next, third step is the knob is then kept in the read position and note down the manometer reading. Left limb how much will come and then right limb will come. Then finally we can calculate the head loss, that is denoted by capital H. The next step is water is now allowed to flow through the selected venturimeter and the flow is made constant. At this flow rate, the difference in pressure between inlet and throat is measured. Okay, then we can calculate what is the diameter of venturimeter device, small d1 and then small d2 should measured. Okay. The next step is the exit valve, the collecting tank is closed and time taken for the tank water to rise by 5 centimeter or 10 centimeter is noted. Okay, based. So finally we can calculate what is the actual discharge and what is the theoretical discharge and what is the coefficient of discharge. Each and everything should calculate. That is the final answer. This is a venturimeter experiment setup, as well as here Orifice also attached. This is the pipeline. Okay, the pipe diameter is already told. Okay, and this is the main supply. This is the collecting tank. In this portion is venturimeter and this is orifice meter. Okay, so now I am going to conduct a venturimeter device. So remaining pipelines should close. Okay, in this particular venturimeter device only open. Okay, this is called manometer. So this is the left limb and right limb. Okay, so in this manometer filled with the help of mercury. Okay, so in this mercury only so at the time of during experiment process in this mercury will be vary. Okay, so in this mercury show the pressure difference. Okay, how we calculate the pressure difference means you can see in this scale. Okay, H2 limb how much and then H1 limb how much will come. Based on thing only we can calculate the head loss. In this left limb is known as head 1. So in this head 1 limb is directly connected to in this pipeline, and then in this limb is H2. Then this is already connected to in this venturimeter device. Okay, so this is called drain valve. Okay, after complete the experiment, all the water should drain from the main tank. This is the tank. So in this tank only very important, because here one measurement is there with respect to time, how much water is filled in this tank. Okay, normally 10 centimeter. So up to 10 centimeter, how much time it will take. So that things we can measure. So before going to start the experiment, first we can measure use with the help of scale how much dimension in this collecting tank. Okay, now we can measure collecting tank dimension. What is the breadth, what is the length. Okay, based on thing only we can do the calculation. The tank length measured. What is the dimension for in this collecting tank? The length of the tank is 59 centimeter and width is 39.5 centimeter, and pipe diameter is 25 mm and throat diameter 16.77 mm. See, this is pipe diameter and this is venturimeter throat diameter. So in this dimension only I mentioned here. Okay. Now I am going to conduct experiment. Now I can switch on. Okay. See the difference. This is the manometer reading. Okay. Now I have to release the air from in this manometer, adjust with the help of in this knob already I done it. Okay. This is the venturimeter pipeline. The pipeline diameter already mentioned 25 diameter. This venturimeter device and throat size is 16.7 mm. Okay. You see, this is the collecting tank. This is the collecting tank. This is the drain valve. Okay. So before measure the value, you should close in this drain pipe because we need 10 centimeter height level. Okay. So in this position, valves fully open. The fully open condition. Fully open condition with respect to time, 10 centimeter, how much time it will consume. This is a full opening condition. So in this condition, how much value will come, we can measure. So now I am going to close in this knob, close in this valve. So now I am going to measure. Okay, now I am going to close in this valve. Okay, now we are going to start up to 10. Okay, so up to 10, how much time? So now the time noted, the time 12.69. Okay, so this is second. Now I am going to open the drain valve. Okay, again we take the pressure variation. How much? H1 is 9.5 and right limb 43. Okay, so after that we can calculate what is the exact head loss. We can subtract in this limb, we will get head loss. So next we can measure manometric head. So diameter of the pipe already given, already measured, and H1, H2 now only observed. Then H1 limb 9.5 and H2 limb 43 centimeter. Then manometric values H is equal to H1 minus H2 into 12.6 into 10 to the power of minus 2. The how much time taken for the H centimeter, rise of water 10 centimeter means 12.69 second. Okay, again we can measure with the different pressure level and then to find out what is the H1 and H2, then what is the head loss, then how much time again you can calculate. Okay, then fill in this tabulation. So now I am going to increase the pressure. Okay, so now I am going to increase the pressure. The flow is reduced automatically. What happen? The pressure will increase. Okay, again I have to close in this drain valve. After increasing the pressure, now I am going to close in this knob. Then again we can measure the height up to 10 centimeter. Starting from 6 but up to 16 you can calculate. Okay, so now time consumed is 18.53. The water level increase up to 10 centimeter. See in this manometer reading, actually the head loss is the left limb is increased and then right limb is reduced. It is depends on the pressure variance. So now completed all 4 trials, okay, with different various pressure difference. First, now I can do venturimeter calculation. This is the venturimeter tabulation. Diameter of the pipe in mm, how much means 25 mm diameter pipe here using. The manometer readings are noted. Okay, left limb and right limbs values are noted and tabulated here with respect to time. The level of 10 centimeter rise of water. After that, we can calculate actual discharge and theoretical discharge as well as coefficient of discharge. So now I am consider first reading the trial number 1. The calculation for venturimeter. The diameter of pipe is equal 25 mm and the length of the pipe is equal to 3 meter and venturimeter dia D1 is equal to 2 centimeter and D2 is equal to 1.36 centimeter. Then we can calculate the head loss. It is denoted by capital H. The formula is 12.6 into H1 minus H2. The H1, H2 values are already tabulated. So the values are 43 minus 9.5 with respect to H1 and H2 and multiplied to 12.6 will get 422.10 centimeter. Okay. So next one is this is the observation. Area of collecting tank is equal to 59 into 39.5 is equal to 2330.5 centimeter square and area A1 is already calculated 4 centimeter square and A2 is 1.49 centimeter square and rise of water H the 10 centimeter and the time taken small t is equal to 12.69 seconds for first reading only. And what is the head loss occurred? 422.10 centimeter. In this 422.10 centimeter already here calculated. Then acceleration due to gravity is equal to 981 centimeter per second square. So now we can calculate what is the actual discharge and what is the theoretical discharge and then coefficient of discharge also. Okay. Now I am going to calculate actual discharge. The actual discharge formula is equal to A into H by T. A means area already calculated 2330.5 into H rise how much level water level is rise 10 centimeter divided by time taken for particular first reading 12.69 seconds. The value is 1836.48 centimeter cube per second. Okay. Afterwards we can calculate Q theoretical. The formula is A1 into A2 into root of 2GH divided by root of A1 square minus A2 square. The values are 4 into 1.849 into root of 2 into 981 into 122.10 divided by root of 4 square minus 1.84 square. The value came 1893.63 centimeter cube per second. Okay. Finally calculated coefficient of discharge Q actual divided by Q theoretical. This is the formula 1836.48 for actual discharge, 1893.63 for theoretical discharge. The coefficient of discharge value is 0.96. Here no unit. this is venturimeter graph. X-axis represent actual discharge, y-axis represent theoretic discharge. Then find out coefficient of discharge with respect in this slope. Okay, in this slope. So that is also easy to find out what is the exact coefficient of discharge for particular meter, venturimeter. The same procedure repeat again for Orifice meter also. Afterwards compare both the venturimeter and Orifice meter value and plot the graph. The graph will come like this. The x-axis represent obstruction opening percentage of pipe, and y-axis represent permanent pressure drop percentage of maximum pressure drop. So this is venturimeter and then this Orifice meter. So always Orifice meter friction coefficient of discharge is always less compared to venturimeter. Okay, thank you.